So in this class we are going to discuss about neural networks. So what it mean neural networks? Also we'll call this one as a artificial neural networks. Why? Why we will call this one as a artificial neural networks? Because it mimics or it works like our human brains. What's the task of human brains? So which and all inputs we will give it to a human brain, it will process that one. So if you are observing any or if you saw any particular animal, suddenly our brain gives decides like whether this one is a, suppose if you saw a dog, it's a dog, not like it's not a cat. It decides how. Before only we are given an input by observing from our eyes. So it takes the input from our eyes, it sends a signals to our brain. In a brain it will process. How it will process? In our brain also we have multiple number of neurons. It takes the input and it decides whether it's a dog or cat or cow or any other element. Finally we will come to know it is a dog. So in our brain also we have different neurons in our brain. Each and every neurons, it contains its own task. Same concept we are adapting into a neural network. In a neural network what we have, so how we have like different neurons in a brain. So it will each and every neurons which will performs its own task and it will process the output and it gives the output to a different next neurons. Similar way here also we have different layers. In different layers also we have different neurons. How we will call this in an artificial neural network we will call it as a neurons, because the neurons nothing but this is the functional body or processing element. That one is also we'll call it as a processing element. These functional body or processing elements, it takes the input then it will process and it will take it will prepare the output. Depending upon the output it decides the neurons of next layer we have to send, or to which neurons of next layer we have to send this output. How our brain decides, like if we saw a lion we have to run, so we have taken an input from our eyes, but it given an action to our leg. So similar way it takes the input from input layers, it processes the output, and depending upon our output, so in our neural network we have multiple layers. So while we are sending the output also, it decides the neurons of next to which neurons of next layer we have to send the input, or sorry, we have to send the output, process the output we have to send. Similar our example, how if we saw a lion we have to run from there, otherwise it will catch us. So same way here we have one example. Here we have different layers, layer 1, layer 2, layer 3, layer 4 and layer 5. From a layer 5 we will get the output. In a layer 1 we will start the input. Remaining 1, 2, 3 layers are different layers. So what the task of this one? Similar way, just imagine we have one paper sheet. In that one we have written some phone number. Because of that maybe rain or some reasons, or it gets faded. So from normal observations we are not able to understand, or we are not able to get that numbers. In that particular time, we will decide whether it is a 9 or 6 or 8. So like that we will decide. How we will decide? In each and every time we will decide whether it's a 9, whether it looks like 9. When we will decide or when we are processing like whether it is 9, in that particular time in our brain, it starts observe the features of 9, whether it contains circle at the top, then whether we have one curved line at the bottom, so like that. If it is there, yes, it is a 9. Again we'll check that curve whether touched to again whether it contains two circles, one above and one below. So if it is definitely 8, so like that we will decide whether it is a 1 or 8 or 3 or 9 or 6. Same way, same task it performs in a different layers. Here we have different layers, no? See, this performs. So neural networks pass an input like image through the multiple layers of digital neurons. So this is the digital neurons. Each layer reveals additional features of the input. We are extracting input features, so special features of that particular inputs. So here we will perform some mathematical calculations in each and every neurons of each and every layers. Then it will produce the output. When the data is fed into a network, each artificial neurons that fires transmits nothing but when we are giving the input to our artificial neurons, automatically it fires nothing but it comes to an action, and it performs the input and it will produce the output and transmit to signals to certain neurons in the next layer. So from there, from layer 1 to layer 2, how it will pass, which are likely to fire if multiple signals are received. This process reveals abstract information about the input. Abstract information, similar like how we will decide whether it is a 9, whether it is a 8, whether it is a 6, whether it is a 3, like that. So depending upon how many number of other than input and output layers, how many number of layers we have, depending upon that, we are categorize our networks, or we are given names to our networks like shallow network and deep network. In a shallow network, SHALLOW, shallow network, we are reducing the number of layers. While we are reducing the number of layers, we are increasing the number of neurons. Because to get a better output, accurate output we need to get, no? That's why we are increasing the number of neurons. So that's why it's called as a shallow network. Because we are increasing number of neurons, it is expensive. A deep network, what happens? Here we are increasing the layers, but we are decreasing the neurons. So because of that, what happens? So number of expense compared to the shallow networks. In a deep network, the expense is very less. So these are the two types of architecture. Depending upon a number of layers, we have decided shallow networks and deep networks. Yes. So neural networks can adapt to changing input. So the network generates the best possible results without needing to redesign the output criteria. So neural networks works for different types of inputs. So that's why no need to change or redesign our network or neural network for each and every different inputs. The neural networks are a series of algorithms that mimics the operations of a human brain to recognize the relationship between vast amount of data. So each and every because it it's a mimic of human brain, so we are not able to generate exact neurons of our uh, human body. So we have to digitally we have to create. If you want to digitally, if you want to create in the sense it to work that one, we have to give a different algorithms. So because it contains number of algorithms, they are used in a variety of applications. So why we need to study these artificial neural networks in the sense it is going to use in a financial field, in a weather forecasting field, a marketing field, in a stock verification, in a stock market also they are going to use this particular concept, nothing but artificial neural network. So what and all components of this particular neural network? The inputs are the measure. So it takes input, it takes the weights, or we have to add different types of weights for each and every inputs. Transfer functions is there in neurons, activation functions is there, and also we have bias. While we are giving an input for each and every different input, we are assigning the different weights. So there is a scalar multiplications or one algorithmic need. Transfer function. While we are giving an input, we know that one our depending upon our input, our digital neurons comes to a action. So this task, because of the activation, it performs some or it comes to action, it performs some task and nothing but it processes the input and it gives the output. That output we have to give, we have to send. Suppose if we are there in the end of layers, last we are there in an end layer, directly it decides the output. Suppose if we are there in a middle of our layers, so still we have some layers, in the sense we have to transmit this output to the next layer. While we are transmitting also, we have to decide, not for all the digital neurons which are there in the next layer we have to send. No, we have to send only to the sum of neurons in a network layers, in the next layers. How it will decide? Depending upon the output. How these output will be transmitted to neurons or digital neurons in the next layer. This task will be performed by our transfer function. While our output is transmitted to our digital neurons which is there in the next layer, that neurons comes to action. So this task will be performed by our activation function. So these are the tasks. So these are the components of a neural network. Till now what we have discussed, this one is the introduction, how our neural network works. Now we are giving in detail explanation about artificial neurons. So these artificial neurons are processing elements how we have neurons in our human brains. Similar way here also we have some digital neurons. That one we will call it as a artificial neurons or processing element, PE, are highly simplified models of biological neurons, our neurons. As biological neurons, an artificial neuron has a number of input. However, our brain contains number of neurons. It also contains number of artificial inputs, neurons. It takes multiple inputs. A cell body, also it contains one cell body and an output which can be connected to a number of other artificial neurons. So from here we need to decide, we need to come to know. So our output will not be sent to only only one neurons of next digital neurons, next neurons which is there in the next layer. Also it sends output to multiple neurons in a next layer depending upon the output. Artificial neural networks are densely interconnected neural networks of processing elements together with a rule, nothing but here we are assigning some rule to adjust strength of connections between the input between the units in response to extensively supplied data. So here we have to send the network output to a multiple neurons in a next layer, not to all. Multiple neurons in the sense not to all, but selected neurons in the next layer we have to send. So this is the our graphical representation of our digital neurons. It takes a number of inputs. So input 1, input 2, input 3. So for each and every input we are assigning weights. Input 1 for this is the first input, we are assigning weight 1. This is the input 2, for this one we are assigning weight 2. Similar way we have multiple weights. Illustrate, this figure illustrates structure of a processing element with the activation function. For this particular node, n weighted inputs, here we are giving input 1, input 2, I1, I2, I3, W1, W2, W3, Wn, so are combined through a combination function. So here we have a combination function. This is the body of an artificial neuron. So in this one, the output which we have, multiple input we have, so that one will be combined with the help of combination function. That are often consist of a simple summation, nothing but again after combining it will perform summation. It comes to takes one output, one sum. A transfer function then calculates the corresponding value, the result yielding a single output, usually between 0 and 1. Here in a transfer function, so after performing combination function, so it decides the, or it performs the, we have to generate the output. That output will be generated by a transfer function. These output will be there usually between 0 to 1. 1.0. So similarly in a fraction point. The combination function and the transfer function together we will call it as a activation function. Combination function and transfer function together we will call it as a activation function. So to transfer function, to perform a transfer in a digital neuron cell body, it uses uses commonly three functions. First one sigmoid, second one linear, third one hyperbolic function. I repeat, sigmoid, linear, hyperbolic function. These are the commonly used transfer functions. So now we are to decide the different architectures which we have in artificial neural networks other than shallow and deep networks. So depending upon a number of layers or the number of neurons, they are decided. Now similar like, but it is a different one. So here we have two main architectures, MLP and RBF, multi-layer perceptron and radial basis function or function. How it is decided too. So the individual nodes are linked together in different ways to create neural networks. In a feed forward networks, the connections between layers are unidirectional from input to output. Nothing but unidirectional, nothing but if you take input from layer 1, it will process that one, it will send to a layer 2. It will not again back, it will not send to a previous, for a previous layer. It will send, it will feed and forward it. So same way. So depending upon how many number of layers here we are going to use, so depending upon that one, here we are going to use categorize the architecture into two categories: multi-layer perceptron and radial basis function. First we will discuss what it means multi-layer perceptron. As its name suggests, multi-layer perceptron is a development from a single perceptron in which extra hidden layers layers additional to the input and output layers are not connected externally. So this one extra hidden layers we are added more than one hidden layers can be used. Generally, the connections are allowed from the input layer to the first hidden layer, hidden layers to the second hidden layer, and so on until to a last hidden layer. Our input will be processed until the last hidden layers. After, when it reaches to a last hidden layer, it will process and it will send the output to our output layer. So because of that one, it contains this particular architecture, it contains multiple hidden layers. We are calling it as a multi-layer perceptron. Here in this artificial neural networks or multi-layer perceptron, we are using sigmoid as a transfer function. Note that we are using sigmoid as a transfer function, in which in MLP architecture we are going to use sigmoid as a transfer function. So MLP contains multiple hidden layers. The input from input layer to a first hidden layer, it will be passed from first to second, second to third, third to fourth, so on up to it keep going till last hidden layer. From a last hidden layer, it sends the output, process the output to a output layer. So this is the representation of a sigmoid function. We'll discuss later about in detail in a sigmoid function. Second category, nothing but or second architecture, nothing but radial basis function network. In a previous one, we had multiple hidden layers. Here we have only one hidden layers. So in a radial basis function network are also feed forward. Similar like our multi-layer perceptron, it's also feed forward, but it contains only one hidden layer. The primary difference between MLP and RBF nothing but this hidden layer only. The rest all are same. One more. Here we are going to use Gaussian transfer function. Gaussian as a transfer function. RBF hidden layer units have a receptive field which has a center, that is a particular input value at which they have maximum output. Generally the hidden units have a Gaussian transfer function. So this one is about our radial basis function, MLP, two architectures. We are given an introduction about artificial neural networks, what it means neural networks, what it means artificial neural networks, why we'll call this one as a neural networks. Each and every cell body or processing elements will call it as a artificial neurons. All these topics we have discussed. I hope you are understood. If you have any doubt, drop it in a comment box. I'll try to clear that. Thank you.